Hey everybody, in this video we are going to focus on what to do in a situation when direct substitution is not a good option for finding a limit. So let's start off with, we're going to focus on number 1 on this list, which is going to be factor and reduce, and then we'll slowly move into number 2, 3, 4 in the next examples. Prior to this, we just went over a few algebra based limit laws or rules. So if you didn't watch that yet, you might want to watch that and then come over here. So if a function is continuous at the value indicated by the limit, use direct substitution, which I will abbreviate as DS to save time and space. However, if the function is not continuous at the value indicated, hint, you will likely get 0 in the denominator if you try direct substitution. This is not always going to be all that obvious. Because of it could be a piecewise and things like that, but for a lot of the cases that's going to be a big indicator for you, okay? At least for now in the beginning. You should try something on the following list. So number 1, factor and reduce. Now the list has a few more things. I actually modified it a little bit, but we are going to focus on numero uno. So number 1, we have this example right over here. Let's see if I could zoom this guy in. How is that? All right. So over here, example 1, find the limit as x approaches 2 of what we have in front of us is a rational function, and it is x cubed minus 2x squared minus x plus 2 over the entire quantity of x to the 4th minus 2x cubed plus x minus 2. Okay, so if I were to unknowingly just dive in and try direct substitution, I would plug in 2, right? 2 cubed minus 2 times 2 squared minus 2 plus 2. I mean, these immediately get rid of each other. They're canceled. Then here, 2 to the 4 minus 2 times 2 to the 3rd. That's times, sorry. Plus 2 minus 2, and that actually cancels out because it's 0. 2 to the 3rd on top is 8 minus 4 times 2, 8 over. Now 0 on top, that's okay. You can get 0 over anything except 0, and the answer would be 0. 2 to the 4 is 16 minus 2 times 8, which is 16, and I get the very famous 0 over 0 indeterminate form. It really doesn't tell us much of anything, but it does tell us, hey, I look like a cute little division symbol over here. So what you want to do is divide or cross something out from top and bottom. Now, there's this other thing called the remainder theorem. And the remainder you get when you do, say, synthetic division of polynomials. So if I divided this synthetically, this numerator or this denominator, if I did synthetic division, and I finished in that last little corner number, a bottom right corner box. If I got 4 is my remainder, but I would also get 4 if I plugged in whatever number I was dividing by. So if I was dividing by 2 in the box, because I was really dividing by x minus 2, right? If I was dividing, then I would get the same answer if I plug that in. I know it's going to seem a little wonky, but if you just notice what happened, right? Oops, I don't want to erase that whole thing. If you notice, I plugged in 2 to the numerator and denominator, and it wasn't that bad, but sometimes it's a lot of work, right? So what else can be done? The number we want to plug in, which was 2 over here, right? If I take that number 2, excuse me, and I do synthetic division with 2, right? 1, negative 2, negative 1, and 2. Those numbers came, I'm just focusing on the numerator. I plugged in 2, I got 0. If I did synthetic division, 1 comes down, bottom times box, add straight down. Bottom times box gave me 0, put it there, add straight down, negative 1. Bottom number times box, this box, I get negative 2, add straight down, 0. The number I get in my remainder, 0, is the output I get if I plug in 2. So as a time saver, in certain cases, it's going to be a lot easier to do this technique. This is foreshadowing a bit for the next example. So now, anyhow, back to the case. So we get 0 over 0. We could factor and simplify. Now this also ends up being a bit easier because factoring by grouping is a clear choice. We can see we have like a 1 to 2 ratio between that term, 1 to 2, 1 to 2, 1 to 2. Having this like common ratio floating around in our problem is great for recognizing a situation where you can factor by grouping. So we have the limit as x approaches 2 of, all right, so I'm going to have to factor by grouping. Here, my GCF is x squared. I'm going to pull that out. I'm left with x minus 2. Minus, here, my GCF is really a negative 1. I'm left with x minus 2 if I pull out a negative 1 over. Down here, my GCF is x to the third. If I pull that out of those two, I'm left with x minus 2. Here, my GCF is plus 1. So x minus 2 is still there. So I'm writing limit because I haven't taken the limit yet. Okay, I'm still finding the limit. So you have to have it there, similar to a square root, right? From here, if I continue with proper factoring, right? We have the limit as x approaches 2. My GCF of the top is x minus 2. I can pull x minus 2 out front. Some of you don't really understand factoring. You just do it like a robot. Pull out x minus 2. From there, if I pull that out front, my GCF, I'll have x squared minus 1 left on the inside. On bottom, similar. My GCF is x minus 2. Shocker. X minus 2. So I can pull out x minus 2, and I will be left with x cubed plus 1. Now, as tempting as it might be, we have x squared minus 1 and x cubed plus 1. We have the difference of two squares, sum of two cubes, to factor this, right? You might want to. But the reality is we don't need to. I'm going to cross that out from top and bottom because that reduces down to 1. It also got rid of, over here, this guy. As I've mentioned in other videos, he is the devil here. He is causing me to get the 0 on bottom, and that is the problem, okay? It's a little devil emoji in the denominator. We've got to get rid of him. So that's why we want to reduce that. Now that we reduce that, now direct sub is an option. 2 squared minus 1 over 2 cubed plus 1. That's going to be 4 minus 1 over 8 plus 1. 3 over 9 reduces down to 1/3. So I get the answer of 1/3. So I hope that this was helpful. This was a, messier example a bit, but usually they're pretty straightforward. Whenever we can factor and reduce, look for a situation that looks like this, okay? Make a note. What do these look like, right? What do these look like? We factor and reduce. It's going to probably have polynomial looking things on top and bottom. Again, not always. We can have a lot of rational exponents and whatnot, but right now, in this class you're in the beginning of doing this, it might look a lot like that. Final answer is 1/3. Hope this was helpful. Watch the next video to go over cases where we want to use longer synthetic division, and I'll see you there. If you are happy and you love it, thumbs it up, and if not, where are they? Not so much. Angry, thumbs it down. All right, but I hope you're happy. That's it for now. Adios.